Hello, business calculus students. What we have here is a word problem that is talking about a function where our input is price and our output is the quantity of digital textbooks sold. We have some statements here. Before we estimate these values, f of 26 and f of 30, let's interpret these statements. Let me call this statement A. What does A mean? Well, that input is price. That is measured in dollars. And that results in a quantity sold equal to 3 million. So when the price is $25, we get to sell 3 million textbooks. This statement with the derivative is more complicated because we have to express a rate of change. Let's handle the number inside first, the 25. That anchors us. Okay, we've got that. When the price is $25. Now remember, from the textbook, every time we're talking about a derivative, we can think of that as when we increase the input by 1 unit, this is how the output changes. All right, if we're increasing the input by 1 unit, that's $1. So for each additional raise in price by $1, okay, what happens? Well, sales go down. We have 0.1 million fewer sales. And notice that I'm dealing with fewer here because I got a minus sign. This makes sense. When the price goes up, we have fewer sales. All right, let's use that to estimate f of 26. So notice what's happening here. We've raised our price $1. Hey, if we raised our price $1, that means that we have this many fewer sales. Now I forgot something. I'd better add it in. So let's take care of that right now. The book will emphasize this, and so will I. We ought to have the term in here approximately, because this pattern won't always be true. It's just a good estimate based on the derivative, and we are talking about estimates here. So how do I find f of 26? Well, I know that I started with 3 million sales. Oops, I said approximately, didn't I? So let's make sure that we're using the approximately equals sign here. Approximately 3 minus 0.1. So that's equal to 2.9 million. In other words, we raise the price by $1. For every raise in price by $1, the number of sales goes down by 0.1 million. Same idea with 30. We say f of 30, the amount sold. Well, we started at 3. Now we're raising the price by $1 5 times. So we're going to go down 0.1 million times 5. And that is 2.5 million. Now please note, again, these are approximations. The function may or may not be equal to these numbers. It's just our best guess given this information. In other words, the derivative tells us the pattern we expect near 25. So we follow that pattern to get estimates.